and welcome everybody to the second part of our tips and tricks to optimize your ArcGIS Enterprise for speed. This is the deep dive. A lot of this at first glance is going to look familiar if you've seen the previous webinar, but I promise you we're going to get real nerdy. We're going to dig in a little bit deeper, and there is quite a bit of new stuff to look at. So let's get the other stuff out of the way. This is about rock. It is our job, it is our sole focus is to architect, deploy, manage the ArcGIS Enterprise Stack suite and desktop applications in cloud and hybrid environments. That is all we do. We don't do any kind of data collection or utility network or anything like that. We manage an ArcGIS Enterprise Stack in the cloud. That's it. We try to stay in our lane and be the best at what we do. Here's some of our specialties. We're partners with AWS and Azure, and we're a platinum partner with Esri, all sorts of really good stuff. But I'm sure you've seen all that kind of stuff before, and generally I don't care when I see that stuff. So let's just quick what we're going to do. Look at the agenda. We're going to look at some strategies that you can use to maximize the efficiency and the speed of your ArcGIS Enterprise. We're going to do that by looking at some common scenarios and issues, and then we're going to go a little deeper. We're going to take a deep dive into some of these solutions or some of these tricks that you can use to hopefully speed up your enterprise. And then I'm going to pass it over to Miles, and Miles is going to talk about some of the best practices. And then hopefully last, we're going to talk, have a little Q&A panel discussion. So I'm going to hopefully leave a little time at the end and we can go over that stuff. Okay, this looks familiar if you were at the last one, but map service draw time. We're going to start digging in right here. A poor performing map service can be a great indicator of the overall health of your ArcGIS Enterprise system, right? Those slow services, they could mean maybe you have an issue with the network. Something's going on with the network. Or that map service could be slow because you've got a data issue, right? It could be on the database side, right? Perhaps you haven't compressed your versions, or maybe you just have some bad data. That slow map service can mean that the actual map service itself is not configured right? It could be drawing slow because that map service has not been tweaked for performance, right? All of these different things can manifest themselves in the form of a very slow map service. So whenever I see a slow map service, I think something could be wrong here, right? They are by far, the slow map services are by far the most common complaint that we will hear when people are talking about their performance of the ArcGIS Enterprise. And there is no one single solution or a fix, but there are lots of a solid list of items that we can actually check. Again, this is more of a detective work. There's no magic bullet. It is a process. So my map service is running slow. Think of it like this. Your entire ArcGIS Enterprise is the patient, and the ArcGIS Pro project and map service is exhibiting these symptoms, right? So specifically right here, the ArcGIS Pro project is going to be showing symptoms, right? If your ArcGIS Enterprise is sick, it's the patient. Pro project, it's showing you the symptoms. So what we would do if someone has told us about a slow map service is to basically go ahead and open up that Pro project that was used to publish that map service. And that's because, generally speaking, ArcGIS Server will render your map at roughly the same speed as the ArcGIS Pro project can, the one that was used to publish that web service. So if you open up the Pro project and the map is still drawing slow, it's also, in most cases, going to render very slowly in ArcGIS Server 2. So that's kind of where I got the whole, Pro is exhibiting the symptoms and the clues on what we can do to fix up the enterprise. We can gain by, looking at these different symptoms. So when we open up that Pro project, we're going to basically start the investigation or start the examination. We want to take a very methodical approach. We want to start looking at each layer individually. We want to see if it could be the one that's causing the entire map service to be slow. Couple of quick tips. Don't turn on your heavy layers at full extent. Set some scale dependencies. Don't have too many layers in the service. Less is more. Perhaps you've dealt with a layer that's just not going to draw fast no matter what. It's possible that that layer may have just too many vertices. That server is working overtime and it's trying to draw all of these features. The most common features or layers that we see that are like this are contour lines and FEMA flood zones. Those are two of the biggies. Those are the ones that tend to be the most problematic. And then last but not least, try to avoid on-the-fly reprojections of your data. People often do not think about that one because Pro just sort of does it for us and we don't think about it and it's easy, but that can become problematic as we will show you here in 1 second. I am going to now flip over and wish me luck, everyone. This is an actual live demo of ArcGIS. So we know 1,000
Hey,
things.
Jason,
Yes,
can you double check your sharing?
I haven't flipped it over yet.
Oh, okay.
You
You
still
haven't
see
shared yet. I don't
I mean,
see anything, sir.
you don't see the
Oh,
presentation?
oh, there it is. It's on a different tab.
Oh,
Sorry,
okay.
guys.
I was like, oh God.
My
All
bad.
right, no worries. Let me get over here. Let me open it up. All right. Hopefully everybody sees ArcGIS Pro now. Yep. Everybody shake their head. Yes. Okay, cool. So here what we have is an ArcGIS Pro project that has some data that we've probably all had to deal with before in the past, right? This is what I was just talking about before. I've got a layer here that's got some very, very complex lines, right? There's a lot of line work. There's a lot of geometry. There's a lot of vertices. So what I'm going to do is first I'm going to refresh, and then I'm going to go ahead and turn on this layer called LiDAR Contours 1 foot. Let's turn it on. And as that's drawing and we're waiting for that to draw, you can imagine that is a lot of data, right? The very first thing I would do is not display this at all. I would set scale dependencies, so this would only show up if I was zoomed in, right? However, let's just say for the sake of argument, we have to display this layer, right? So I would think about it and I say, well, do I really need a 1 foot contour? Maybe I could get away with just displaying a 2 foot contour, right? It looks almost the same. The difference between 1 foot and 2 foot is, surprise, 1 foot. You're not really losing a whole lot there. So I'm just going to go with the 2 foot contours. Now that drew fairly quickly. Let me hit refresh again and we can see it. All right, not bad. However, that probably, oops. Oh, I turned on the wrong one. Sorry, I went out of order. Oh, sorry. This is the 2 foot contour, right? And we see how that drew. Now, if I turned on a simplified version, what I did was I ran this layer, the 2 foot contour, through a simplification process. If you ever need to look and check that out, you can look, a good one is simplify line. That basically, if we look over here, it simplifies lines by removing relatively extraneous vertices while preserving the essential shape, right? Meaning if the line has a big curve, we can still show that curve accurately without 1,000 different vertices along that curve, right? So it removes a little bit of the fidelity of the curve, but not enough to where you're going to notice it, right? So again, here's my 2 foot contour draw. Let's refresh. Okay. Now what happens if I did a 2 foot contour that had been simplified? As you can see, that drew substantially quicker. So let's put them both on together. And what I'll do is I'll zoom in a little bit. So if I've got the 2 foot underneath and I turn those on, you don't really see a whole lot of difference, right? Let me zoom in a little bit further. And let's be honest, we're down to 1 to 56. I think that's about as close as you would ever potentially want to go on a web map, right? So here you can see some really, really minor differences in the two different contour lines. But when you consider just how much faster the simplified version draws, I think we probably all agree that it's a much better idea to lose a little bit of that fidelity for a draw speed of 10 times faster, right? So let's zoom out just a little bit more. So now I've simplified those contours. What if I could take it another step further and I did it, I made vector tiles out of that layer. Let's see what that looks like. Hopefully you guys noticed that was essentially instantaneous, right? There is no penalty. Those tiles are created, and once they are served down to the client, it's instantaneous, right? Panning, zooming, everything. It's perfect. So think about the different types of data that you have to display. Think about the most effective way that you can serve that data out the fastest, right? In this case, to me, the vector tiles wins every time, right? Here we are, the original. And here we are, vector tiles. I think you guys see the difference there, and the difference is speed, and the difference is the CPU power that's required to actually push that image out to the browser or push those features to the browser, right? Next, what I'd like to show you is, again, something I don't think a lot of people think about all that often, and that is data reprojection. Here's our 2-foot contour that we looked at before. And now I am reprojecting this data in a different coordinate system, right? Did everybody see just how long it took to draw that? Again, let me flip it over here. This is its native coordinate system. See how fast that is? And this, let me refresh here. This is in a not native coordinate system. So the data is in Web Mercator, and I believe I'm reprojecting this on the fly to state plane, right? Pretty clear that is a major, major performance penalty, doing that reprojection. So try to avoid that at all if you can. All right, let's get back to the PowerPoint. All right, do a quick deep dive on your data. So if your data isn't drawing fast like you expect, obviously that's going to impact your performance. So let's take a little bit of a deeper dive on the data and some of these gotchas that you can check for. The first one, and this is a biggie, if you're working with traditional versions in the Enterprise geodatabase, make sure that you are routinely compressing that database. If you aren't, that means the database is working overtime on the back end, trying to piece together all your data layer from lots and lots of different multiple tables. And this can really, really slow down. I've seen this happen a lot. If you're working with a spatial view or a table join inside of Pro, always, always try to make sure to have those join fields indexes. That is going to dramatically increase performance, right? Also, don't forget about your data maintenance routines. You're going to make sure that your indexes are being rebuilt and optimized on a regular basis. Have you ever seen just sort of weird behavior from a layer? I've seen slow draw times from data that looks like it should be quick. Check the spatial index, right? In Pro, check that spatial index. Sometimes they're gone. I've seen it happen plenty of times. Just rebuild it. Check and repair geometry. Seen really weird data layers that were imported from maybe CAD or another source, and they've got topological errors. So you can run that through check and repair geometry tool, and that can often show you what data is bad and help you repair it. And lastly, and this is true for all types of different map services, but it's especially true for feature services, which is basically streaming all of your data directly to the browser. Only ask for what you need, right? So just like I showed you just a second ago with Pro, and display, we can also optimize, speed up your queries, right? For example, maybe you have a parcel layer that's got 60 columns worth of data. Does that end user of your application, does it need all 60 columns worth of that data? Paring this down to only what is needed can really, really help. Like optimizing that query will save you a huge amount of time. So let's take another look at a demo. Again, live demo, folks. See if I can not blow it. All right. So here we have a REST endpoint, and I've got the developer tool console open up on the bottom. And what we're going to do is we're going to query the same exact layer 3 different times. And I'm going to show you just how this thing can differ in the response times. So first, this is a statewide parcel layer. I'm going to make my where statement 1-to-1. So that essentially selects everything, right? The fields that I want, I'm going to get all the fields. I want to include my geometry. Look good. Okay. So I'll go down here and I'm going to return it as JSON, and I'll hit go. So here we have on the bottom, this query is running. We can see it's up to 7 seconds, 8. Okay, well, it finalized at just about 7.5 seconds. And the amount of data that it took to download was about 3 megabytes. Okay, so that's, almost 8 seconds and 3 megs. That can be it's pretty big. So if I'm looking at the same query, okay, I'm still going to select everything. But instead of all of those different, if we go back here, look at all these fields, right? Do I need all of that stuff in my application? No, I don't. So I'm just going to pick 2. I'm going to do the owner name and the parcel number. I still want to, return all the geometry. So I'll scroll down and I'll hit go. And again, it starts returning data. So we're 3 seconds. Oh, all right. So you can see, as opposed to almost 8 seconds, we're down to just over 3. And the size of the data went from, 3 megs to 2 megs, right? You can tell that's a pretty substantial improvement. Now, let's let's go and pare this down even more. So again, I still want to select all the features. I just want to get owner name and parcel number, but I just realized I don't need to return all of that geometry for all of those features. I'm just clicking a box, right? I just need to open up a table and show this data. So I'm going to hit false, and I'll scroll down, and let's see how long this one takes. Oh, wow, okay. Less than a second, 89 milliseconds, and the size was 88 kilobytes. Hopefully, you guys can see that is much faster, way more efficient. Not to mention, on the server, it's much more efficient, but on the client side, that has to actually take this data, parse this data, and display the data, it's much easier on the client. So again, the takeaway here is only ask for what you're going to use. Only ask for what you really need for your application. All right, here we go. There's our query optimization demo. Okay, now this is probably one of the most impactful things that you can investigate. And that's your ArcGIS server map service configuration, right? And we're going to pay, in this case, particular attention to how the map services are configured on the server, right? As many of you probably know, when you publish a map service, it gets assigned to a process running on the server called an ArcSoc, right? This process sits there and it waits for people to send requests. So when that request comes in, it's going to respond, and then it waits on the next request. Well, if you can imagine, you have a very, very popular map service, right? And let's say that one map service is being accessed by the public. There's going to be hundreds of people trying to request a map from that service that only has one ArcSoc, right? So a good way to, I guess, explain or think about this ArcSoc is you think of it as a door, right? If you have hundreds and hundreds of people that are trying to get into your room, right, and you only have one door, a lot of people are going to basically need to wait and get in line. So think about if you could add more doors to that room, people would be able to get in much, much quicker. And it's very much the same for a map service. You can add more ArcSocs to effectively add more doors for people to access your map service. So by default, a map service can spin up 2 ArcSocs, but depending on the traffic that you may be experiencing, you could bump that up to maybe 4 ArcSocs, even 6. And let's give you a quick demo of this. Again, remember, we're doing it live. Okay. Here we have, hopefully everyone recognizes Task Manager here, right? This is on the server where I was just showing that demo. Command line, this is one of the columns that by default is not turned on, but I always like to turn this one on, right? It's great to be able to see what specific ArcSoc that we can see right there corresponds to what map service right here, right? We can see, we can see in this case that this map service only has one single ArcSoc allocated to it, right? So that is essentially one door. So if we flip it back over, here, hold on, I'm looking for my, there we go. Oh, that wasn't it, sorry. If we flip it back here, we go to the manager, and we can see I've only got one instance running, right? So if I edit that map service and I go to pooling, I can see I've only got one instance per machine, and by default, it's always set to 2, right? But let's just say for the sake of arguments right now, I'm going to give it 6 instances. That makes me, that's essentially me opening up 6 doors, right? So hit save and restart. And I'll try to flip it back to the server. Now, hopefully we'll see multiple. There we go. See, now we have 1, 2, 3, 1, 2, 3, 4, 5, 6. That's, I know everyone talks about ArcSocs and how many ArcSocs you have and blah, 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 all this. It's tough to kind of visualize that until you can actually see it in the task manager, right? You can see these different processes running in the back end. Now, that's my super popular map service, right? Don't want to overdo it. I don't want to go over 6 in most cases. We're not going to solve an issue like this of traffic by just adding more ArcSocs. We need some more beef, kind of more CPU horsepower beefcake kind of behind the scenes. Because we don't want to just keep adding map services here, because each ArcSoc that we add is going to increase, it's going to take up this valuable RAM right here. That's the, I guess that's the penalty, right? So I mentioned like we don't want to take resources away from other map services. That's because each one of those dedicated SOCs that we see spins up and uses RAM, which can be a very precious commodity on the server. So if you run out of RAM, your server will crash, right? So if I spun up 20, 30, 40 ArcSocs, each one of those is going to eat up a bunch of RAM, and then eventually my server is just going to crash. We have some options on how to mitigate that issue, right? So like I said before, when we publish these map services, it gets a dedicated ArcSoc on the server. So we want to use these dedicated ArcSocs for our very, very popular and heavily trafficked map services. This process, basically when it's dedicated, it's ready to serve your request right away. And there is a penalty for it. And again, like I said, it has to reserve a lot of RAM for that privilege of being ready. These are called dedicated services. But now consider we've got some other services that we don't use. We have a lot of other services that probably don't get hit all that often. We can publish these as shared instances, which effectively publishes many, many services into a small handful of these dedicated shared instances on the server. So I want to show you those. That right here, if we can see that, that is the dynamic mapping host, right? So what will happen if I flip it back? There we go. And I'm going to edit this again. And I'm going to go from a dedicated to a shared. And I'll hit save and restart. And there we have our dedicated ArcSocs, and they should be disappearing here in just a second. They went away, and they have now been loaded into the dynamic mapping host, right? It's a way to be able to publish and serve out a lot of map services, but kind of try to keep the RAM down on the machine. It's obviously, if you use a shared instance, there is a penalty for this too. That service has to first load into memory. So you might have to wait a couple of seconds for that service to actually perform the initial load. The best thing for you to do is to jump into your ArcGIS manager and look at the logs, check out the statistics, and try to identify the services that would be best used for dynamic mapping, or the shared dynamic mapping host, or ones that are highly trafficked use dedicated services. Okay. All right, I get to take a break.
All right, this is where I'm gonna take over.
All you, Miles.
Guess I'll replace the current share, and I'm gonna share. Hang on a second. Let's go up here.
I think while Miles, you're switching gears. Oh, you already did. But one question came in. Jason Harris, do you have a rule of thumb, ArcSoc versus concurrent connection?
Do I have a rule of thumb? Say that question one more time.
It was, do you have a rule of thumb, ArcSoc versus concurrent connections?
Oh, so that's how many people are attempting to request that map concurrently. I really don't. I base most of my kind of education off that on educated guesses based off the total amount of traffic. It's really hard to get the number of truly concurrent users unless you're doing some hardcore load testing. That certainly using something like JMeter is a really good way to figure out how many concurrent requests your server can handle. But if you're doing any kind of load testing or any kind of wondering, definitely you're going to want to be on a dedicated instance for sure.
Yeah, I would agree with that. Definitely also along that line of thought, if I'm losing my thought actually.
Where did it go?
I don't know where it went.
Well, let's go back to best practices, and then we can.
Well, it'll come back. I think I'm going to touch a little bit on a lot of things here, but basically, I wanted to touch base on the architecture side, really drive home workload separation. So we want to increase the speed and efficiency of ArcGIS Enterprise. And one thing I really, really want to drive home is the architecture pattern of a multi-machine site as opposed to an all-in-one. If anyone's familiar with the standing up ArcGIS Enterprise, you can stand it up all on the same server, or which is an all-in-one, where you have portal, server, data store, the web adapters, even all on the same server, and that's serving the entire site. Kind of simplifies scaling resources in some ways, because then you just turn that server off, add more resources to that single box, and then you're good. However, it does pose issues, and it makes things complicated when you're troubleshooting an issue. If maybe you have a memory leak on that single server, and application crashes, the end user might just say, "Oh, portal's down," but the reality is one of those components failed, and then you have to put a little bit more effort in identifying what maybe caused, what maybe happened, and what resources are actually down. And so it really makes it challenging to troubleshoot. So I definitely don't recommend it for a production environment. Dev, you can get away with, but again, if you're doing like a QA QC workflow on an application that's supposed to look and act like the one in production, maybe that wouldn't be a good option. But a multi-machine site, on the other hand, is where you have portal on one box, server, your hosting server on another, your data store, your relational data store on one, and then your web adapters on the web server. And having that workload separation where all the components are on their own resources, it allows you to scale what's needed, and as your site gets bigger or you just need more resources and you recognize, oh, well, ArcGIS Server is kind of the workhorse engine of ArcGIS Enterprise, then maybe we just focus on giving the resources that server needs, and the web server we can keep light. It doesn't need a lot of CPU RAM compared to the ArcGIS server side or something like that. Uh, Another good best practice is if you have other third-party web applications that you're serving up around this environment, keep them on their own web server. Ideally separate from the one hosting your web adapters. It just cleans things up, and if you need to, you can always incorporate like a load balancer in front that would ensure that the loads are directed to the necessary servers appropriately. And then I also wanted to talk about relational data store in terms of architecture. Relational data stores is great in that it allows for portal users to create content at will if you have the permissions, and it's easy to create things, but it can get out of hand quick, And so I just want to say that my recommendation is really leverage the hosted services specifically, because that's the content that's created in the relational data store for maybe testing, and try to stray away from high use operations, just because it's kind of a black box. It's a component that we, like the GIS administrator, doesn't really have good control over or access to, and honestly, from a scaling perspective, you can't configure in a multi-node configuration. The big data store, you can do that. Spatial temporal, you can do it. Even object stores, you can, if you set it up on a server, you can configure, a 3-node server site for it. But relational, you're limited to just one server, and so it doesn't scale as well. The other thing I wanted to highlight, because this is a relatively new component, is the object data store. And the object data store it does a couple of interesting things. One, it's the replacement for the tile cache. So it's hosting your 3D scenes and even does some HTTP response caching, which is really cool. I'm going to get into, but basically you can configure this on a server itself as using the ArcGIS data store installer, or you can configure it if you're in the cloud, leveraging like an Azure bucket or an S3 bucket, and so it's just object store in a cloud store essentially, and that's really flexible, and so and I think that going forward, we're probably going to see more and more use, especially as things take off to more things like digital twin and more 3D analysis. I think that object data store is going to become more important, as well as helping out hosted features, managing them. And that's what I want to touch on. So there's this cool function called HTTP response caching. Esri has a great article on it, but basically everyone is using hosted features. and for good or for bad, some maybe even abusing them. But the point is, there are queries running against hosted features, and uh, whenever, just like Jason showed, the hosted features are kind of being processed through through some of the services and there's another uh, process called the Java W exe, and that's kind of handling the hosted feature requests within that on the hosting server. And so that then gets pushed to the relational data store. Relational data store gives a response back to the server, and the server takes that and makes the images, whatever it is. That's kind of in a nutshell how hosted features are getting served back to the content, to the web map or the dashboard or whatever. But some environments use hosted features a lot, and hosted features that can have an impact on how the hosting server is performing. That puts a load on the hosting server, and if you're trying to if you want to increase efficiency, it would be helpful if there's a way to kind of cache some of this responsing. And so Esri came out with this, and what you can do is you can go into the super secret admin endpoint within the rest directory. I highlighted it so you see on the hosting server, and you find your hosted feature. You give it the layer number, and it's an update definition. And you would go in here and provide some JSON input to enable HTTP response caching. And what that does is it allows for query responses to be stored in that object data store, in addition to its functioning as hosting 3D scene layer caches and stuff like that. And so you just would get a quicker response on a given query. So I think that's a really cool function. I think that we're going to see it used more often, and in a lot of ways, this is taking some of the pressure off of the hosting server and relational data store for around managing some of these query requests around the hosted features. So I thought that was really cool. I wanted to highlight that. And I also wanted to talk about.
I was going to ask you, Miles. So you mentioned like data or machine separation.
Yes.
So should the hosting server be different than like a regular ArcGIS server, or should we just put it all on the same machine?
Oh man, I love that. Yes, it should be different. So if you have a small site, like a base deployment, some people will double the use of an ArcGIS server in that it will be designated as the hosting server, serving hosted features from the data store, as well as using it for published map services and published feature services that are referencing, say, an enterprise geodatabase. I've even seen it where they'll even tack on an image license and serve up image layers, which is not recommended either. You're just putting more hats of responsibility on a server site. So with workload separation, ideally you want to have reference services on a different server site than your hosted server. Now, if you're not using a lot of hosted services or whatever, I mean, that's fine. This is all up to your organization and how you want to use your site. But the recommended approach is to have dedicated server site for map services. Even some of, like, for example, some DOT organizations will have dedicated server sites for their roads and highways integrations. Airports will have dedicated server sites for indoors. It's up to you to how you want to logically group it, but definitely keep your hosting server kind of separate and leverage just for hosted features in the relational data store.
Awesome. Thank you. Yeah, that's exactly what I wanted to know.
And on the relational data store, it's really important to go back and clean up stuff that you create. Again, it's too easy to create anything and everything, and before you know it, month one you might be, oh, we've got a few hosted services, and then 6 months in you have hundreds, thousands. It everyone I think everyone would agree that the more that enterprise GIS is used in an organization, uh, the bigger it's going to get, and it's not like organizations stop. Very rarely would we see an organization that stops using GIS. I think I've always found it to where they just keep using it even more. And that's the same case with the relational data store and hosted content. So, um, yeah, I just want to mention that maybe every once in a while, go back and see what kind of hosted features and hosted content you're creating, and go back and clean it up. And that kind of gets into some of the data governance, and I'll touch base on that a little bit too. I got to move a little quicker though. Another cool thing I found out uh, starting 11.4, since 11.4, Jason was talking about creating indexes, attribute index and spatial indexes on your data that you're serving up. Well, you can do that with hosted features, and it's really neat. So if you go into Portal and you go to the hosted feature on the settings tab and you scroll all the way down on a feature that are hosted, you'll see where you can add attribute indexes or field indexes and then spatial indexes. And if you have a hosted feature that's being leveraged for some operational use that's changing constantly, if you go and update that spatial index, that's probably gonna improve the query performance on that. Um, you know, and the general rule of thumb with field indexes is identify those fields that are actively being queried, queried against, and put indexes on that, and that's going to improve the speed and efficiency in your hosted features now. So I thought that was really cool, and I wanted to highlight that because I think it's about time we have that capability. But again, the data store has been a black box for a while, so in that we haven't had a lot of control or options yet, but we're really seeing some cool things. So starting 11.4, 11.5, and beyond, there's a lot of really helpful innovation around this. With all that, I want to get into touch. I'm going to try to be brief, but I think it's really important is data governance. And I grabbed this from the architecture site, and I'm not going to read it. I'll just kind of summarize it. I'll jump in the middle. Governance guides which solutions get developed, who does the development based on skills and availability. So it's really, really important as a GIS organization to have a vision and planning and strategy. We'll call it a GIS operational strategy around their enterprise GIS and the applications that get created. This is a very forward-thinking perspective, and it's really, really hard to get right, and it's really, really hard to do, but it's doable. When you can start to establish standard operating procedures, at least around things like managing portal content, how you create your features and tables in a database, um, you know, how that data is maintained, getting into maintenance, of the database, etc., tuning services, tuning it at the ArcGIS server level as well as tuning it at the data level. How your portal content is just managed. Portal has helpful tagging around authoritative content versus deprecated content. Use that, and also how your data and GIS project folders are organized, whether it's on the file server or even in ArcGIS server. I don't know if you guys have ever looked in the ArcGIS server manager, but when you publish a service and it has a long name, it's really, really hard to read. if you're ever trying to use the ArcGIS server statistics. So I, even how things are named and structured, I think it's really, really important. So I really wanted to touch base on this because it's hard to do it right, but whenever you can actively work to this, it really makes for a robust and stable organization. And you get less and less reactionary issues. So we've already talked about service tuning, but oh man, that didn't show right. But basically, I wanted to also highlight on the portal content, knowing your system resources. With 11.5, there's an About tab that highlights a report essentially of your server sites and available CPU and RAM, which is just a really cool way to summarize your system. I thought it was really cool. I wanted to share that. I didn't share it very well on this slide, so apologize. But and then coming back into this, Jason already talked about some of this. He talked about the minimum and max instance settings. Again, an ArcSock is only able to process one request at a time, and every ArcSock is having an impact on the available memory on the system. So be sure to you want to be able to identify which services need the most attention and which ones don't. And then you look at that shared versus dedicated, like Jason talked about. And as far as applications go, when you're creating dashboards or experience builder, think about the services that you need and the problem it's trying to solve. If you're doing a web application with a map interface that you need to serve up images, think about referencing an image service for that little portion, that window, whatever it is. But if a function or application is querying something, leverage a feature service. Feature services handle query responses that are more optimized for a query versus serving up an image. So that's kind of a helpful little tip to think about as you're designing your GI solutions.
That's a really good point, Miles. I kind of glossed over that a little bit, but yeah, when the ArcSock, if it's sending out a map image, it can only use one, right? And feature services can use multiple, and that really, really speeds things up. That's awesome. That's great.
And then this is kind of goes without being said, but I'm going to say it again. Especially engineering firms, I find where you have lots of active projects, new projects. Sometimes you publish services to represent a particular project, then a month later you're done with that project. Go back and see how those services are being utilized. Do you still need that service? Can it be turned off? Can it be removed? Again, you got to jump into Server Manager. It's up to the GIS admin to get in there and kind of maintain those services. And if they're still running and you don't need them, that's just using unnecessary resources that may be finite. All right. And then the last thing I wanted to touch on was the ArcGIS server statistics. I think this is one of the most underrated, underutilized, helpful things. If you can just jump in and look. But you can basically look at a few different statistics, and one of them is like the total requests for a given service or a site. You can look at the entire site, all the requests, and then you can also pare down to different folders. You see I have that hosted check. That's all the hosted services in that folder. Bear in mind, if you have 1,000 hosted services, you're going to need to use that search bar to find the service you need, and it's going to be challenging. But in this example picture, you can see that the green line is this operations map that's getting a lot more requests coming in than the hosted services, much less, right? So this site is leveraging more dedicated resources than that. So in this way, you see an easy snapshot of, okay, how is my site performing? Where is the activity?
Hey, Miles, something I've been digging into lately is this server report right here, statistics is great, but there's so much more that you can do on the back end, just using the ArcGIS admin API. So if any of you guys are handy with Python, you can make these
Oh yeah, Python notebook.
reports and make these requests and get really detailed reports about all your services. It's really cool.
Yeah,
I've been doing that a lot lately. Yeah, it's cool.
That's a really good point. Yeah, that's another thing about the newer versions is, again, the API is generally getting better and better, more capability, giving us more insight into the environment. It's really, really important. Another statistic is the max instances running. So, we set that minimum and maximum. This is where you can see how often those max instances, or how often a given service is running at max instances. So in this example, that operations map has a max instance of 2, and it has been running at 2. But just because it has a max instance, it doesn't mean it's always going to be using 2. I see it dip down to 1 periodically, but this is also a good indicator of seeing, okay, if I have a max instance of 6, and I'm not entirely sure how often it's getting up there, maybe I don't need it. I don't need that max instance so high. Maybe I can adjust this down a little bit. So that's useful to look at. Average response time. This is another great indicator. Rule of thumb, you want a good running service is milliseconds, sub-second. But I would say that anything under 2 seconds is a flag, like, hey, we really need to focus on these services to figure out what is causing this response time, and this example, 4 seconds, that's a long time, but I've seen it where, response times are in the 10-second range, and that's average. It's not even max. The other one is the max response time, and then you see something like this where every once in a while, the line of requests trying to use the door gets piled up, and things get stretched out to a whole minute or more. Usually this is indication of maybe just high traffic at a given time on a system, and in addition to problems on the local map service, we need to maybe take a look at that. But again, these are just basic statistics that any GIS administrator can go in their server site and look at, and really just get a quick idea of where's my traffic at, and how are my services performing. So I definitely encourage everyone to just look at those. And with that is all I have.
Thank you so much, Jason Harris and Miles Harris. Really appreciate it. We sadly only left a few minutes. We got to figure out how to leave a little bit more time next time. But I think some of these we might have touched on later, but I'll just go ahead and ask a couple of them. I think this one is, how do I know how many ArcSocs are available based on RAM? And is, like, as far as the ArcSoc processes, is it more efficient to have one larger service or several smaller services?
Those are great questions. So I'll start with the larger services versus smaller ones. I think it's I'm in the camp that you don't want to have a large monolithic service, because if a service is referencing 100 layers, it really gets challenging to troubleshoot
Yes,
if the service is
preach
performing.
it, Brother Miles, preach.
I think that the playing in the middle, you want to publish map services, logically grouping things that are related to each other, but don't overdo it. I mean, I think easily 10. I don't know. There's no real rule of thumb. It's up to you. But I think smaller services that you can use to, like, isolate more problematic layers, like a parcel layer, for example. That's one of those that really easily gets out of hand, and it's not always very well maintained. I would keep that out of on its own. And then you create your web maps, and you're able to pull in multiple services just fine. But it's going to allow you to kind of keep a thumb on the problem areas. Anything to add on that?
I was going to say that to the second part is, it's hard to know how many ArcSocs you're going to be able to use, because each one of the services that gets associated to the ArcSoc can take up vastly different amounts of RAM, right?
Mm-hmm.
One ArcSoc could use 100 megabytes and for one service, and then a different service could use, I've seen ArcSocs up to 900, almost a gigabyte of RAM. So it really depends.
Yeah, I think you could kind of play with it sometimes if you take the total memory in a system and then you rule out the memory usage by like the Java W and the Java processes and stuff like that. And then you can kind of sort of figure out an average memory footprint. You could sort of get a high idea, but yeah, it's variable. It could be more, it could be less. And so it gets into this game of a judgment call. So you just gotta monitor that closely,
All
like
right.
Jason said.
We are at time.
Oh,
There's more questions than we were able to answer, but we will do our best to either consolidate them into something on the website or reach out with some responses directly. Thank you so much, guys. This was a really great session today. For those of you who joined us, if you could just take a quick, if you have any input on what you would like us to tackle in a future webinar, we of course have opened a poll here. We would love any feedback. We do these for you guys, and also to kind of geek out. I know that's also part of why we do them as well. But any feedback we really appreciate. Thank you for joining us today. And again, we will reach out with the recording, and have a great rest of your day.